Everyone to the next exercise on offline bin packing. Here we know that our bin size is for every bin 1, and we would like to compare the first fit decreasing and the best fit decreasing heuristic with each other. We know that both of these heuristics have a quality of 1.5, 1.5, and one hint for solving this A and B is that we would like to have a sequence of all items that has a length of 6. Okay, so in the first task, we would like to compare the first fit decreasing heuristic, and in B, we would like to compare that with a best fit decreasing heuristic. Okay, so you could imagine every kind of sequence of length of 6 like you want to, and you should play a little bit around to try to compare both heuristics and how they behave. Here we would like to have an example sequence of, let's say, 1.4, 1.4, 1.3, 1.3, 1.3, and 1.3. Okay, so this is a randomly chosen sequence. Okay, we know the optimal solution from just looking at it. So we know we would require 2 bins. Okay, and we would assign the 0.4 to 1 and the second to the second one, and then fill it with a 0.3, 0.3, and the same for both bins. Okay, so then we have fully packed both bins. Okay, and we know in the worst case, the first fit and the best fit decreasing heuristic would lead one solution that is 1.5 times better than the optimal solution. Let's check if this is true. Okay, so let's do the first fit and the best fit decreasing algorithm and compare that. So for both cases, what we have to do is, first of all, we have to order it in a decreasing order. So this is already done. And now we have to assign, when using the first fit, we would assign the first 0.4 to the first bin. Okay. And then also the second one to the first bin. Okay, so this is the first bin, this is the second bin. Okay, and this would be done for the first fit, but also for the best fit. Okay, we try to fill the first bin as much as possible. Okay, so the next 1.3, that doesn't fit anymore into the first bin, so we open a new one and place it to this one, and the next one 0.3 also fits into it. Okay, so that's fine. So both heuristics would give us the same solution, and the third 0.3 that doesn't fit into the first bin anymore anyway. So in both cases we would assign that to the second bin. So, but still we have this 0.3 item left. So in both cases we have to open independently. If we use the first fit or the best fit, we have to open a third bin and assign that 0.3 to this third bin. Okay, so it doesn't matter. Okay, so it is indeed has a quality. So this is here the quality C. Okay, which gives us the worst case scenario. So it's indeed 1.5 times worse than the optimal solution. Okay. Okay, here you can see it nicely drawn. Okay, and the next task is now to find a sequence of items again, so basically the same with again possibly different sizes, but that these two heuristics yield different, right? Different bin assignments for those items. Okay, so we would like to get some kind of example to show that a first fit and a best fit would lead to different results. Okay, and again you can play around with different numbers. Here we have again an example sequence. Okay, and let's assume we have a 0.8, 1.5, sorry, 0.5, 0.4, and 0.1. Okay, so we don't need to have the sequence of 6 anymore. That was only valid for A and B, but here we can choose another size, and let's do it with this one. And let's start with the first fit decreasing heuristic. Okay, so we have to open the first bin, obviously. We have again to order it in a decreasing way. It's already done. And of course we would now fill the first bin with this first item, which requires 80% of the capacity of the first bin. That means the second one doesn't fit anymore into the first bin because it requires a capacity of 0.5. So we have to open a new one, second bin, okay, with 0.5, and then choose the next one, 0.4. It only fits into the second bin. Okay, so the next one, 0.1, can, and this is first fit, we would need to assign this one to the first bin that has enough capacity. That means we would fill first of all the first bin, because this is the first bin that has the capacity available. Okay, if we do the best fit decreasing heuristic, we start the same. We have to order, and then we have to assign the first item to the first bin. Okay, and the second which requires capacity of 50% doesn't fit anymore into the first one, so we open a second one. Okay, we have half of it filled, and here we now have a third request, third item of 0.4. Okay, so we cannot assign it to the first bin. We only can assign it to the second one. So this is the same solution as before, but the last one, the last item, which requires 0.1 of capacity, that would be assigned to the second bin, because then the remaining capacity is minimized. Okay, so here we don't have any capacity left anymore. The second bin is filled to 100%. In contrary to this one, in the first fit decreasing, you can see here if we would place it into the first bin, we would still have 10% left. It would only be filled up to 90%. Okay, and we still have 10% left. But the best fit requires that remaining capacity is minimized. Okay, and this is the case for the second bin. It's 0 capacity which is left. Okay, and with this I would like to thank you for your attention.